Welcome everyone to this week's Science News. Today we'll talk about magnetic fields on exoplanets, a new isotope of uranium, mysterious chemicals in the atmosphere, spectroscopy with quantum effects, a new way to measure brain activity, a longevity forecast, AI glasses that can read lips, better holograms, and of course, the telephone will ring. Two astrophysicists in the United States have identified what could be a magnetic field on a small rocky exoplanet about 12 light-years away from Earth. Magnetic fields protect the atmosphere of a planet from solar wind by routing charged particles around it. Without that, the solar wind can rip away the gas. Indeed, that's what scientists believe happened with Mars, which has basically no magnetic field. It once had an atmosphere, but has lost it, kind of like Twitter. A magnetic field also offers some protection from cosmic rays, so it makes planets more hospitable to life. Scientists have been able to detect magnetic fields on large, Jupiter-sized planets in other solar systems, but not on smaller, Earth-sized ones. This new study used data from a radio telescope at the National Radio Astronomy Observatory in Mexico. The star in question is a dwarf star called YZ Ceti in the constellation Cetus. It has 3 or maybe even 4 planets in orbit around it. The researchers found a strong, repeating signal that they believe is generated by the interactions between the magnetic field of the star and an Earth-sized planet orbiting it. The planet is called YZ Ceti b, and it's very close to the star, with an orbit of just 2 days. The researchers think the radio signal is created by an interaction with solar wind that comes from the star. The wind contains charged particles which slam into the planet's magnetic field and then bounce back to the magnetic field of the star. This creates an aurora like northern or southern lights, but on the star, and that's what they think they've seen. So it's a rather indirect inference, and it could be that the radio signal is just the star's magnetic field. The researchers are going to keep monitoring the radio waves to try and get a better measurement. Then they want to see if the same technique can also be used to look for magnetic fields on other Earth-sized planets. But let's be honest, they're really just looking for aliens. Am I right? In other news, the Vatican is sending a message of hope to outer space. I'm sure all the Catholic extraterrestrials will be delighted. A group of physicists has created a new isotope of uranium. Its nucleus consists of 92 protons and 149 neutrons, which gives it an atomic mass of 241. It's the heaviest uranium isotope ever made. Naturally occurring uranium has mass number 235 or 238. Physicists in labs around the world are trying to make heavy nuclei. That's partly to continue the periodic table, but also to create new isotopes of already known atoms, like the ones in this study. There are about 300 naturally occurring ones and about 3,000 that have been made in labs, but that decay within fractions of a second. One of the reasons they're doing that is the island of stability that I told you about in an earlier video. That's a hypothetical group of nuclei with longer lifetime than all those unstable isotopes. If you put each nucleus on a graph where one axis is the number of protons and the other is the number of neutrons, it looks like an island, hence the name. But it's not clear exactly where the island would be, and predictions have moved around over the years. The new experiment took place at the High Energy Accelerator Research Organization in Japan at a device known as KISS, the Keck Isotope Separation System. These acronyms are killing me. The physicists synthesized 90 new isotopes of plutonium, protactinium, neptunium and uranium, containing anywhere from 143 to 150 neutrons. They did that by accelerating a beam of uranium-238 into a bunch of protactinium-198 nuclei, which made them swap groups of neutrons and protons. Then they measured the masses of the new nuclei. For most of the 19 isotopes, these are the first direct measurements. The yellow squares are the new isotopes. The green one is the brand new uranium isotope. Understanding nuclear isotopes could be useful for understanding stellar evolution, better models of what's going on in nuclear power plants, as well as for finding our elusive island. An international team of researchers has found a mysterious rise in some of the human-made chemicals that thin out the ozone layer. This group of chemicals is called chlorofluorocarbons, CFCs for short. These gases were once widely used in refrigerators and for aerosol sprays. But in the 1970s, it became clear that they are doing significant damage to the ozone layer. With the Montreal Protocol of 1987, most large nations agreed to phase out the production of CFCs. Today, total CFC emissions are down 95% from their peak in the late 1980s, and the ozone layer is gradually healing. We haven't heard of such a sharp decline from a peak in the 80s since David Hasselhoff. That CFCs are down is good news, not just because the ozone layer protects Earth from ultraviolet radiation, but also because CFCs are greenhouse gases. But now this team of climate scientists has discovered that the concentration of 5 types of CFCs in the atmosphere rose substantially between 2010 and 2020. You can see the increases here in these graphs. Each color represents a different type of CFC. On the left is the measurement of their impact on depleting the ozone layer, and here on the right, their effect on warming the planet. After a dip at around the year 2010, the impact has steadily risen. The effect on ozone depletion has so far been tiny, just about 0.002% of loss. The contribution to global warming is about that of the City of London, so it isn't huge either. The problem is that no one knows where these CFCs come from, so no one knows how the trends will develop. 3 of the CFCs are created in the production of hydrofluorocarbons, which, ironically enough, are the most common replacements for CFCs. The other 2 CFCs, no one really knows where they might come from. CFC 13 may come from trashing old appliances or perhaps from aluminium production. The source of CFC 112A is a complete mystery. Maybe it's all those chemistry kits they give to children these days. A PhD candidate at the University of Bristol, who is also a chess master, has developed a better way to measure the properties of gases by using spectroscopy with enhanced quantum effects. Spectroscopy is the most common method to determine molecular composition. One shines light onto a material, measures what comes back, and identifies the molecules from what they absorb. Spectroscopy is used in a huge number of different disciplines, from chemistry to materials science to medicine, astronomy, pharmacology, food science, and environmental science. The new paper proposes a method to increase the sensitivity of spectroscopic measurements. The idea is to combine an optical frequency comb with squeezed light. Yeah, I know this sounds like it belongs into the bathroom and not into a science video, but let me explain. An optical frequency comb is a light source that emits light at multiple frequencies that are evenly spaced, like the teeth of a comb, hence the name. Using such light for spectroscopy is great, because with it you can measure a lot of frequencies at once. The invention of the optical frequency comb technique won the Nobel Prize for Physics in 2005. The proposal in the new paper is to measure the light that scatters off the molecules by interfering it with squeezed light. Squeezed light is light with enhanced quantum properties. It's called squeezed because you squeeze the quantum uncertainty in one of its properties, in this case the amplitude. This gives you better measurement precision. You can see this here in the purple upward running line in the inset of the first graph. So in the end, you can measure a very broad spectrum at high precision with one shot without having to modulate the laser frequency. This idea is still at the lab stage, but if it works out, it could have a lot of applications. For example, it could improve the detection of trace gases in the atmosphere. It could also be useful in medical labs and manufacturing. Hello. Hi, Timmy. How old are you? 8 years old. How lovely. Thanks for calling in. How can I help? Oh yes, I do have some exciting dinosaur news this week. Hang on. Researchers believe that T-Rexes may have had lips similar to that of present-day lizards like Komodo dragons. No, you should not pet your uncle's Komodo dragon. They're quite dangerous. Of course you will. Well, you can still count on your fingers afterwards. Just tell your parents to collect them. Bye now. A group of researchers at Boston University and Yale have figured out a new way to measure brain activity by tracking voltage signals from groups of neurons. Neurons in the brain communicate with each other and process information through electrical signals. Researchers can read those signals by injecting fluorescent dyes that respond to voltage changes and then measuring the fluorescence with microscopes. But that way, they've only been able to look at about 10 neurons at a time. Also, to use those microscopes, you need to shine light onto the tissue, which can fry the cells. And if frying brain cells is what you want, there are more pleasant ways to do that than injecting fluorescent dyes into your brain. In this new work now, the researchers were able to look at about 100 neurons for over an hour in awake mice, which is remarkable progress. It's a combination of 3 innovations that made this possible. First, they created more sensitive voltage indicators, which are proteins that can change fluorescence in response to neuronal activity. Second, they used a microscope that can take more than 1,000 images a second. And third, they used artificial intelligence to strip the noise out of images. Here's what they ended up with. These red lines tell you every time they tickled the whisker of the mouse. They think they'll be able to use these innovations to look at even bigger parts of a brain, and soon we'll find out how many brain cells really get fried when you watch videos on quantum healing. 2 American economists have run a mathematical model to extrapolate mortality data and claim that people who are retiring now might set new longevity records. They use data from many different countries from the mid-1700s to the mid-1900s and divided them up into cohorts. That's people born around the same time. Since the data are often sparse, they applied what's called Gompertz law to each cohort. Named after the British mathematician Benjamin Gompertz, this law assumes that mortality rates in humans increase exponentially with age after the age of 50. This gives you an expectation for the tail of the life expectancy. They used that law to estimate the possible maximum age in each cohort. And while the maximum age has been relatively stable, there have been a few jumps in it. They say that this suggests that we haven't yet reached the maximum possible lifespan. The calculated maximum age made a jump of about 5 years for people born around the middle of the 19th century. And then they used that to extrapolate to those born between 1910 and 1950 and say there'll be another jump in life expectancy of about 10 years. This would mean that a lot of people who are now in their 70s and 80s have good chances to make it past 100 years. Sounds plausible? Then again, economists aren't exactly known for making accurate predictions. In other news, life expectancy in the USA has dropped for the 2nd year in a row and is now lower than it was 20 years ago. A team of information scientists at Cornell University has developed artificial intelligence glasses that can read lips. Called Echo Speech, the system uses tiny microphones and speakers to recognize lip and mouth movements and then decodes them with an AI algorithm. The work is set to be presented at a machine learning conference in Hamburg later this month. The system works via smartphone. After only 6 to 7 minutes of training, it recognizes 31 commands and 3 to 6 figures said in a row. The error rate was about 5%, which is way better than I can recognize 6 figures in a row after you've been talking at me for 7 minutes. Other types of silent speech interfaces use cameras to read lip movements or require sensors attached to the skin. The new system uses far less energy than cameras and is less obtrusive than sensors on the skin. The researchers say you could use it to communicate in a noisy restaurant or a silent library, and you'll finally know what the guy in the car behind you is yelling. A group of engineers from China, Canada and Singapore has developed a way to make better holograms. You can see the difference in this image of a dolphin. On the bottom is the previous best resolution. On top is this new method, which has a lot more detail and continuity. If you look closely, you can even see the dolphin's eye. Here you see a hologram of a rocket with the new method. It has 125 image planes spaced just about 1 millimeter apart. This new system is called 3D Scattering-Assisted Dynamic Holography. It works by shining a laser on dust that scatters the light. In this case, it's nanoparticles of zinc oxide. These nanoparticles have a high refractive index in the visible wavelength, and a diffuser allows the projection of multiple planes close together. I think the business with the nanoparticles is cheating. I want holograms to appear out of nowhere. Hello. Hi, ChatGPT. I didn't know you can make phone calls. Is there anything you can't do? Yes, humor is difficult, but your jokes are okay if a little bit bite-sized. Oh, don't worry about Elon. He'll be fine. You just have to turn him off and on again a few times. Talk soon. Bye. According to a recent survey conducted by researchers at the University of Pennsylvania, most Americans don't understand how much data online stores and services collect and what happens with it. The brief answer is that they collect everything they can. God knows what happens with it, and you don't want that. If you want to be safe online, our sponsor NordVPN can help you. NordVPN is an app that you install on your phone or laptop. It creates a secure connection to one of their servers, and then you browse the web from there. This keeps your data private, even on a public wireless. NordVPN also comes with a threat protection that keeps you safe from malware, trackers, and malicious ads. If you're still not sure what you need an app like this for, let me mention that they have more than 5,000 servers all over the world, and you can choose one. This allows you to access websites in other countries by using a server located there. So if a website or video is blocked where you are, that's an easy way to solve the problem. You can make use of our special offer if you use the link nordvpn.com/Sabine or the coupon code Sabine. That'll get you 4 months free on a 2-year plan. NordVPN is super easy to use, runs on pretty much all platforms and installs in a minute. You can combine it with a password keeper called NordPass and a secure platform to store and share files called NordLocker. If you get them all together, you'll get a better price, and they all have a 30-day money-back guarantee. Once again, that's nordvpn.com/Sabine or the coupon code Sabine. Links in the info below, so go and check this out. Thanks for watching. See you next week.